Good morning. Welcome to the final week of Math G. This is Professor Cardetto back in California, and I'm going to do a couple mini videos. Actually, I'm going to do a mini video today on homework 22. As you can see here from the screen I'm showing you, I opened up homeworks 13 and on, and so that you guys can prepare for the final exam. This week sometime I'm going to make the final. I'll make a review sheet as well, review a set of problems for you to do. That's optional, but it'll be also on Connect Math. Homework 22 is what we'll go over today. I will preview the assignment here. It's also what the lecture today will be going over. So I want to talk a little bit about some notation. What we're going to start this week is something on sequences. And there's two types of sequences. There's arithmetic sequences and there's geometric sequences. Today we're going to talk about the arithmetic ones. Basically, what an arithmetic sequence is, it's just a set of numbers separated by a comma that have some type of pattern. Okay, like you could have like this pattern: 2, 4, 6, ... Okay, and those are just the even numbers. You could have 10, 20, 30, ... and those are just the multiples of 10. Anytime you have a sequence of numbers, there's always a one that's first. So that first one is called a sub 1. So you'll see these little subscripts. A sub 1 is equal to your first term, your first term in your sequence. Okay. Now there is a pattern. There's a pattern that goes on in both arithmetic and geometric sequences, and so the pattern is what we're adding to or subtracting. They don't have to go up, by the way. I mean, you could have a sequence that goes like this: 5, 3, 1. And what would the next one be? Let's see. You subtract 2, you subtract 2, you subtract 2, so it's going to be negative 1. ... Okay. So what we have here is a gap that's in between the first and the second term, and what that gap is called is the common difference. It's the difference between the second term and the first term. So D is called the common difference. Common because it's the same for all numbers. Common difference. Okay, so if the common difference is positive, like this one, the common difference is 2, because you add 2 each one, then you go up. And if it's going down, then the common difference is negative 2. So that's what we're doing. We're subtracting 2 each time. For this one here, 10, 20, 30, the common difference would be 10. That's what we're adding. So the first problem here just asks you to write the first 5 terms of the sequence. Okay, so they give you the first term. So that's going to be 7. And then it tells you what the common difference is. The difference is also 7. So what we're just doing is we're just adding 7 each time. So add 7, add 7, add 7, add 7. Okay. Multiples of 7. All right. Let's see. Let's go look at number 5. Okay. Number 5 gives you the five terms of the sequence and asks you for the common difference. So just what's it going up by? It looks like it's going up by 4. So simply put 4. It's as easy as that. Let's go over number 11. Okay. Got to be careful with the fractions because when you check the box, you'll see a little fraction bar there. You do not want to go into decimals or mixed numbers. So um, always start with the first term. They gave you the first term as 1. Put 1. Now, they give you the difference as 1/4. So how do we add 1 plus 1/4? 1 plus 1/4. 1 plus 1/4. Well, that's 1 and 1/4, but we can't put 1 and 1/4. And we don't want to go do decimals, not 1.25, but we change this. We change this to a improper fraction. Hopefully you guys remember how to do that. 4 times 1 plus 1 is 5/4. Or we could do this. You guys remember the big number 1, right? The big number 1. The big number 1. That one right there, I just wrote as a bubble letter. That's 4/4 plus 1/4 is equal to 5/4. So we're going to put 5/4 right there. 5/4. And then it's pretty easy. Add 5/4 plus 1/4. You get 6/4, 7/4, 8/4. So 6/4. Let me see if they want them reduced. Let's just check this out for a second. Because 6/4 can be reduced to 3/2. 7/4 can't be reduced. And let's see, 8/4 can be reduced to 2, but let me keep it as 8/4 just to see if it tells you to reduce it. Okay, so I'm going to click check answer here in a second. It might give me the red X because 6/4 can be reduced to 3/2 and 8/4 can be reduced to 2. It doesn't say anything about reducing to lowest terms here, so it might work. It does work. Okay, so we don't have to worry about reducing your fractions to lowest terms. I'm sure it'll also accept 3/2 and 8/4. 8/4 is equal to 2, but that's a good thing that it gives you credit for that. Okay, a couple more problems here. Let's see, 13. Okay, 13 asks you to write the nth term of the sequence. Okay, so we need to, you guys need to write down a formula here for the nth term. Here it is. Grab a pen, write it down. This is for arithmetic sequences only. Okay, a sub n is the nth term. This is going to be the nth term. Why do I say nth? Well, n could be any number. This is the nth term. Could be the first term, could be the second term, could be the third term, could be the 10th term. It all depends on what this number here is. Okay. A sub 1 is the first term. Then you add a plus sign, parentheses, n minus 1 times d. So this is your first term, like I talked about before. First term. N is the same as this n. This n. This n is the same as this n. And that's usually your number of terms. Your number of terms. Number of term. And then D is your common difference. Okay, so they're looking for a formula here. The nth term can be written as, all right, so let's see. It already has the a sub n right here. A sub n, that's this part right here. So they're not asking you for the fifth term. Obviously, they wouldn't ask you for the fifth term because the fifth term is right here. That is the fifth term. They're asking you for a formula for the nth term. So here it is right here, a sub 1. So we put in a sub 1. A sub 1 is 4 plus parentheses. Parentheses don't work. don't know why my parentheses don't work there. Maybe it's my keyboard. Um, Let me see. Well, what's the common difference? It's -2, so it's going to be -2. Put this in. Maybe you want to put a -2 in first. So -2 parentheses. No, it's not putting the parentheses in. Okay. Let me check out the way they want this written. Clear my screen. And okay. Okay. So they want you to write it as a. Oh, they want you to multiply. Okay, so the parentheses aren't going to. We're going to distribute through the parentheses. All right, so I'm going to try another one here. All right, I know how they're doing it. So we go a sub n equals a sub 1 plus, this is the same formula I just wrote down. They just wanted you to write it in a little different order. So we're going to write this as 9 is the first term. They always give you the first term here. Plus n minus 1. It's always n minus 1 in the parentheses. And then the common difference here, it looks like it's going up by 4. Okay, so now, reason why you couldn't add parentheses in there is they want you to distribute this 4. So you distribute the 4. So this is 4n minus 4. And now you can go ahead and combine the 9 and the 4. So that's going to be 4n. 9 minus 4 is 5. So it's going to be 4n plus 5. Now, so this formula generates each of the terms. Now, what do I mean by generates? Well, if you let n be 1, if that's 1 and this is 1, you should get your first term. 4 times 1 is 4. 4 plus 5, 9. 9 is my first term. Let's see, if n is 2, you should get 13. So if n is 2, you should get 13. If n is 2, 2 times 4 is 8. 8 plus 5, 8 plus 5 is 13. So it's a equation that gives you the value of the term, and that's how we're going to put that in there. Let me just double check here. 4n plus 5. My answer should be okay. All right. Let's go over number 16. Clear my screen here. Okay, it says find the indicated term of the arithmetic sequence in which a sub 1 is equal to -5 and d is equal to -5. Okay, so let me write down the formula again. I always start by writing down the formula. A sub n, a sub 1 plus n minus 1 times d. Okay, now I know a sub 1 is -5. So this -5 right here goes right here. I know d is -5. A sub 10, they want you to find a sub 10. Okay, so this is going to be a sub 10. So 10 is your n, so that means you plug 10 in for n. And then you just do the math on the right-hand side. 10 minus 1 is 9, so it's going to be 9 times -5. So 9 times -5 is -45. And -5 plus -45 is -50. The 10th term a sub 10 is the 10th term is equal to negative 50. Put that in here, negative 50. Okay. All right, last one, problem 20. Find the number of terms, n, of the arithmetic sequence. Okay, so this one here has this little dot, dot, dot there after the third term. It's dot, dot, dot. And then we don't know, like negative 43, if that's the 30th term or if that's the 27th term, or we don't know how many terms there are there. I guess we could do it using brute force and just actually write it all out. It looks like it's subtracting 2 each time. So I could keep on doing that and subtract 2 each time. But I really don't want to do that. I don't want to go subtract 2, subtract 2, subtract 2, subtract 2. I mean, it's going to take me forever to get to negative 43. Okay. There's a certain number of values here. We call those number of values n. So we have a formula, though. Always go back to the formula. A sub n equals a sub 1 plus n minus 1 times d. I'm going to let a sub n be this term right here, negative 43. Now, I don't know if that is the 20th term. I don't know if it's the 30th term. Remember, I don't know how many terms there are here. So if I don't know something, I'm going to let it be a variable. I know a sub 1. A sub 1 is 1. I don't know n. I don't know n. So I'm going to let it be n. I know d. I know d. D, it goes down by 2 each time. Each time it goes down by 2. So I know d is equal to negative 2. Look what I got here. I got an equation here. I can solve this equation for n. I can solve this equation for n. You guys remember how to solve an equation, right? Let's distribute this negative 2. So it's going to be 1 plus 2n, and then negative 2. Actually, this negative 2 is going to make this a negative 2n. So let's see. Erase this part right here. This is going to be a negative 2n, and this is going to be a positive 2. So this is 1 plus 2. So this is going to be negative 2 plus 3, or negative 2n plus 3. So I now can subtract 3 on both sides. So I get negative 46. And I get negative 2n. And I've divided both sides by negative 2. It would make sense that n has to be a positive number, right? You can't have a negative number of things. We're trying to find out how many numbers there are here. Can't have a negative number. Got to have a positive number. So negatives cancel. 46 divided by 2 is 23. So that would mean that there are 23 terms here. Just type in the number 23. Okay, much more today during lecture. Module week 8 module should be open, but there's no discussion this week. We'll be talking more about the final in future videos. Bye for now.